ladies and gentlemen, and welcome to our second video on lesson 10.4. And in this video, we are going to concentrate on compound events. It will not be a very long video. And you were asked to take just a few notes. There was a little tiny blurb at the top of page 424. I'm going to add to that, so you might want to jot some of this down as we go. First of all, compound events is the probability of two or more events. Okay, and we've dealt with a little bit of this. We just didn't call it compound before. I think it was mentioned briefly, but certainly not in something that you were asked to remember. You know, in a simple event, the example of that is if I roll a number cube and I can get a 4 or a 5. That's one roll, so that's one event, okay? And there's one outcome. Now, if I have compound event, I can roll a number cube and get a 4, and then I roll it again to get a 5. So there's two separate rolls with two separate probabilities that I would then multiply together to have compound probability, which we did quite a bit in our last lesson. Okay, to find the probability of two or more events, you simply multiply the probability of each event. Just like we did with the fundamental counting principle. That's basically what we did. So, excuse me. Example number 7 says you're taking a true-false quiz with 10 questions. Assuming you answer every question, how many different ways can you have, can the test that you just take be answered? It's only 10 questions, and they're only true-false. How many outcomes for each question? That's right. There's 2. It's either true or false. So our first question, there's 2. Our second question, 2. And then 2 and 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 2 until you have 10. And when you multiply all that together, you would understand that that's actually 2 to the 10th. And when you multiply all that together, you actually get 1,024 different ways to answer 10 true-false questions. Wow! But there's only one way to answer them to get them all correct. Woo! So you got to be smart. Guessing's not going to work too well. Probability is not very high. Very unlikely you're going to guess very many of them correct. All right, example number 8. A game system allows players to design a personal picture. Each picture is designed by choosing from male or female 8 face shapes, 48 eyes, 12 noses, 24 mouths, and 82 different hairstyles. Heavens to Troy, I guess there's a reason why I do not play video games. However, the question is how many different pictures are possible? Whew. Well, I guess they want a lot of variety when people choose the game to play. All right, so what are the events? Well, the first event, male or female. How many possible outcomes? 2. That's right. You're either male or female. Then you get 8 face shapes. So that's 8 more possibilities. 48 eyes, 12 noses, 24 different shaped mouths. I can't even imagine how many different shaped mouths they can come up with on that one. And then 82 hairstyles. I'm telling you, they must have some funky looking hairstyles. All I'm saying. But hey, I've seen some crazy hairstyles coming to school. It's all right. It's all right. I think it looks cool. I wouldn't put it on my head, but it looks cool on yours. Anyway, here we go. So we have to multiply all of that together, and holy smokers, when you multiply all that together, you get 18,137,088 different face pictures. That's a lot of different faces, babes. A lot of different faces. All right, moving right along. Example number 9, our last one of the night. It says you need to hang 7 pictures in a straight line. In how many ways can this be accomplished? So right underneath that, write an A. And let's think about this. We're going to help ourselves because we're going to draw a picture. I have 7 pictures. Picture number 1, picture number 2, and 3, and 4, and 5, and 6, and 7. So I want to hang these on the wall, and I want to know how many different ways I can hang them. So we got to think for a second. I have 7 pictures. How many outcomes, how many possible ways could I hang the first picture? That's right, there's 7. Because there's 7 pictures. I could put any one of the 7 pictures up first. Let's move to the next one, number 2. How many different ways can I hang number 2? Well, some of you are going to say 7. And if you say 7, you're not thinking. Because we already hung number 1 up. So there's not 7 now. The number of outcomes possible for the second picture is only 6. Because we already used 1. Now when we go to picture number 3, do we have 6 left anymore? There's 2 pictures hanging on the wall. So we only have 5. And it keeps going down. 4, 3, 2, and when we get to the last one, there's nothing left to choose from. It is what it is. So now we can use our fundamental counting principle to multiply the number of different ways we can hang 7 pictures on a wall. And when you multiply all that together, you find that your answer is 5,040. That's a lot of ways that you could hang 7 pictures on a wall. How about part B? Part B says, if the picture of your great-grandfather must be in the middle, how many ways can the 7 pictures be hung? So we have to think again. Nice that we have our picture already. So which number would be in the middle? That's right, number 4. So number 4 has to stay. Well, if number 4 has to be one picture, how many outcomes are possible? Yeah, only 1 for the one in the middle. So we know that one goes in the middle. So how many could be hung here in the first spot? Well, that's right, only 6, because we already used the great-grandfather. And then 5, and then 4. Only one way to put one in the middle. And then there's 3, and then there's 2, and then there's only 1 left again. So now we have 6 times 5 times 4 times 1 times 3 times 2 times 1. And that leaves us with only 720 ways. So just putting one picture in the middle decreases the number of ways we can hang the rest of our picture down to 720. Pretty amazing stuff. By the way, this type of probability has a specific name, and we'll get to that in one of our later lessons. Ladies and gentlemen, we're done. A license plate must have 2 letters followed by 4 digits. Quick write number 2, part C says, how many license plates are possible? So, first of all, how many events? Think, how many events? And then how many outcomes for each one of those events? Ladies and gentlemen, come to class tomorrow with some questions, please, on compound events and fundamental counting principle. Begin working on your assignment. Finish off your 45 minutes with quality effort, using aggressiveness and urgency to get things done, making sure that you are always using your time effectively. Get into the habit of not wasting time, and you will find that all the stuff you have to do comes much more easily. Ladies and gentlemen, always a pleasure. Thank you very much. I will see you tomorrow.